Okay, so where we left off on the first video was that we had 2 pyruvate and 2 NADH and 4 ATP from glycolysis. Remember, a net of 2. So the next step is called pyruvate oxidation. And we're going to take that pyruvate and we're going to move it into the mitochondria. And we're going to use a little carrier called coenzyme A to do that. So this is our coenzyme A. So in forming coenzyme A, the pyruvate has to be oxidized. So what happens is NAD comes in, picks up a hydrogen, becomes NADH, and then you lose a carbon dioxide. So we're going to remove a carbon and 2 oxygens to make carbon dioxide. And when you do that, now you only have 2 carbons left. So this is acetyl, and when it's in the little boat, it becomes acetyl-CoA. So acetyl-CoA then gets transported into the mitochondria. And of course, the same thing's going to happen with the other pyruvate, but I'll get back to that later. So remember, in that step, we also make carbon dioxide, which is then exhaled. Okay, so now we are here at acetyl-CoA. So notice that we moved into the mitochondria. We're in the center of the mitochondria, which is called the matrix. The matrix of the mitochondria. And in the matrix is where we do the citric acid cycle. So the citric acid cycle is when we basically burn the rest of glucose. So what's left of glucose now is here in this acetyl-CoA. So we're going to turn the carbon into carbon dioxide, and we're going to take all this hydrogen and we're going to make NADH, and we're also going to make something called FADH. So we're going to move all the hydrogen onto these hydrogen carriers, and we're going to burn the rest of the carbon. That's the main goal of the citric acid cycle. So the way it works is the first step, there's a 4-carbon compound called oxaloacetate, or OAA. Notice it has the 6 protons, so it's still carbon, but I'm just making it yellow so you can tell the difference between that and the carbon coming from glucose. Okay, so what I'm going to do is I'm going to kind of ignore the oxygen because it gets a little unbalanced because water comes into this cycle. And so you're just going to have to trust me that it all gets balanced. But we're mostly going to focus on the carbon and the hydrogen. And I'll show you how the oxygen's involved. So when you have OAA and you connect this acetyl group to it, you have a 6-carbon molecule called citrate or citric acid. Once the acetyl group comes off of CoA, CoA can go back and pick up another acetyl group from glycolysis. So now we've made citric acid. That's why this is called the citric acid cycle. So citric acid has 6 carbons and a bunch of hydrogens, and of course oxygens as well. So in the citric acid cycle, remember the purpose is to burn these 2 carbons and make them into carbon dioxide and move all these hydrogens onto hydrogen carriers. So what we're going to do is the first carbon comes off, it combines with oxygen to make carbon dioxide, and that is exhaled. And then the hydrogen is going to be moved to NAD to make NADH. So in the citric acid cycle, you end up making 3 NADH. So we're going to load up our NADH here. And then you lose another carbon, make carbon dioxide. That's exhaled. And then the last hydrogen goes on to a hydrogen carrier called FAD to make FADH, which we'll talk about later. And then you end up with your OAA again. So OAA is always recycled. It's just going to pick up the acetyl group. You're going to burn the acetyl group. You're going to move all the hydrogens to NAD and FAD to make NADH and FADH. And then you end up with the OAA again. You can start again. So let's go ahead, since you might need to hear this again. Let's go ahead and do it with the other pyruvate. Okay, so here's our other pyruvate, remember from glycolysis. And the first step is we're going to oxidize pyruvate and pyruvate oxidation. And so to do that, we take a hydrogen and we put that on NAD to make NADH. And then we remove a carbon dioxide and we breathe that out. And then we have what's left over is acetyl. And the acetyl binds to CoA to make acetyl-CoA. The CoA goes inside the mitochondria. And then the acetyl group is transferred to OAA to make citric acid. And the CoA goes back. Now we have citric acid or citrate. And then all this hydrogen is going to, 3 of them are going to go onto NAD to make NADH. And 1 of them is going to go on to FAD to make FADH. And then these 2 carbons are going to be burned and connected with oxygen to make carbon dioxide. I don't have any more blue blocks, but that would also make carbon dioxide. So, and then again, remember you end up with OAA again. So the OAA is always recycled. So the products of the citric acid cycle are carbon dioxide, which is waste, and you make 6 NADH and 2 FADH per glucose total. So in the last video, we're going to find out how we're going to use all this FADH and NADH in oxidative phosphorylation to make ATP. Oh, I forgot one other important thing is you also make 1 ATP in the process of the citric acid cycle per acetyl group. So you make 2 ATP in the chemical reactions that happen in the citric acid cycle. Okay, so in the third video, I'm going to show you oxidative phosphorylation. So that was just the citric acid cycle that you just learned. Okay.